My name is Tim Martin. I'm the Executive Director for the Irrigation Innovation Consortium. I want to welcome you to the session, which is entitled, previous slide, Susie. Yep, Improving Irrigation Efficiency and Management, where we are and what comes next. So next slide. So my name is Tim Martin. I'm the Executive Director of IIC. The abstract, the overview of this session is we will have an updated look at some of IIC's recent research projects, a survey of industry needs, and a dialogue about needs and approaches to increase irrigation technology usability and adoption. Next. I want to talk just a moment about the IIC. We are an alliance of industry partners, university researchers, ag and landscape, in both ag and landscape irrigation. Our goals are to accelerate development and adoption of efficient irrigation technologies and practices, to provide opportunities for collaboration and research, and to advance institution and cross-disciplinary understanding. Next. Our current funding model is that we secure funding from non-federal funders in the amount of $5 million. This is over a 5-year period. We are now coming toward the end of year 3 coming toward the end of year 4 out of a 5-year period. We take funding that we solicit from universities, private and public sector, and we match that with funding from the Foundation for Food and Agriculture Research in the amount of $5 million over 5 years. Next slide, please. Our priority areas of research include water and energy efficiency, remote sensing and analysis tools for improved irrigation water management, system integration and management, and acceleration of technology development. Next, please. These are some of our partners that participate with the IIC. Across the top, you see the university partners from the left, Fresno State, Kansas State, A&M, University of Nebraska, Water for Food, host of this event, and Colorado State University. These are the 5 university partners in the IIC. It is headquartered at Colorado State. These are some, below that are some of our industry partners. We have many more. These are some of the originals or the founders and the consistent partners that we've had over the years that have made our organization successful to date. Next slide. So today we have a very interesting and informed batch of presenters and panelists. We're going to start with 4 presentations. The first one by Derek Heeren. He's Associate Professor and Irrigation Engineer at University of Nebraska-Lincoln. He's also a faculty fellow at Water for Food. He'll be followed by Jay Ham. He's a professor of environmental physics and micrometeorology at CSU. He will be followed by Inge Bisconer, owner of Surf and Earth Enterprises, and she is recently retired from Toro Ag. And then Amy Kremen, the project manager at IIC and the Ogallala CAP. So after these presentations, then we will bring on some panelists. That would include John Turner. He's Chief Sustainability Officer at Netafim. I think many of you, I'm sure, know him from his 10+ years at the Irrigation Association. Weston McCary is the Director of Precision Ag and UAS Technology at Northwest Kansas Tech College. And Jake LaRue. He is now an irrigation consultant at M&J Consulting, and he is recently retired Director of R&D for many years with Valmont Industries. We feel very fortunate to have put together such a highly informed and a diverse group of presenters and panelists. And I'm sure that this will be a very insightful and interesting presentation and discussion. I want to also encourage you to use the chat. We will take questions, and that we will have questions along the way. After each of the presentations, we'll take one or two. And then after the presentations are done, we're basically going to encourage and facilitate questions and answers and dialogue, et cetera, with the panelists, which will be amongst the presenters, the panelists, the whole crowd. So please feel free to use the chat. We'll be reading what you have to say and using that to help us help with the dialogue. Next slide, please. I believe that would be yes. All right, I'll turn it over now to Derek Heeren for his presentation.
Right, thank you, Tim. So my name is Derek Heeren, and really appreciate the opportunity to present here today. I'm going to present on one of our projects that's through the Irrigation Innovation Consortium, and really thankful for that support. The IIC has been really great to work with. The project is also in a strong cooperation with Belmont Industries. Jake LaRue is on the panel, so you'll hear more from him later, but he's been a big part of the project as well. So like I said, I'm Derek Heeren. Also, I wanted to mention the co-author on my presentation is Sandeep Badi. He is our PhD student who is doing the majority of the actual work on this project. And so he helped develop several of the slides in the presentation today. All right, next slide. Okay, so just a little bit of background information. This is probably familiar to all of you in the audience, but I thought it'd be helpful just to mention quickly. So irrigation is a big part of our desire for food security and water security. I think that irrigation is an important part of the solution, not only for increasing food production, but if we compare irrigated versus rain-fed water use, the irrigated field in general will have a higher water productivity per inch of water used. Anyway, so it's an important part of the solution, and we want to make the best of that and use it efficiently. Got a map showing just in the United States, center pivot use. So of course that has an impact on our water resources. We want to account for that from a watershed scale, from a pumping scale. So this specific project focuses on technology with the idea that our technology can help us improve our efficiency, or more specifically what we call irrigation application efficiency. And that's especially helpful to water quality. If we're using less water for irrigation, we have less deep percolation and less runoff that can take chemicals with it. And then the last comment here is the specific motivation for this work is I really think that for our pivots in particular, if we can move more towards automation, I think that will help adoption rates of our technology. So we've had recommendations for irrigation scheduling for a long time. Adoption rates are relatively low because of the time required. So if we can take advantage of the growing number of sensors we have available and data analysis, move towards automation, that would be excellent. Just a real quick side comment. Some of the figures here I took from a textbook that we're in the process of publishing called Irrigation Systems Management. I wanted to mention that partly because Water for Food was a sponsor of that book, and Peter McCormick wrote the foreword. So if you're interested in a book that gives sort of a broad overview of irrigation, you could check it out. So I already mentioned a couple of the partners in our project. Again, the IIC in particular. These are some others. The United States Department of Agriculture has been really helpful. Susan O'Shaughnessy and Steve Evett. They have some specific technology for irrigation scheduling that we are incorporating into this. So I'll describe that a little bit more as we go. Jake LaRue is retired from Belmont, but still provides that connection, and then a handful of other faculty. Also Christopher Neal, and he is on the call today as well. So you will see him later. Next slide. So for our research, we installed a new irrigation system. It was a valley center pivot. It's on a quarter section of land. So, you know, the typical scale for a commercial field production. One of the neat things is that this pivot has an X-Tech drive. And so that allows the center pivot to make a complete revolution around the field in only 4 hours. And is really a significant drop in revolution time compared to the traditional transmissions on most center pivots. That's really helpful for us because we're putting sensors on the pivot itself, on what we call the pivot lateral, the large pipeline that goes down the pivot. And it's really advantageous to be able to run the center pivot quickly without water running. So we can measure the crop canopy while it's dry. If we're gonna not irrigate to do that, we don't want to stop irrigation very long. So to only have to turn the water off for 4 hours instead of say 8 hours is really helpful from a practical management perspective. Sensors on the pivot, that's part of the system that's called SCADA, and that's where the USDA comes in. They've developed the technology for this, of in particular sensing canopy temperature from sensors on the pivot lateral, then doing analysis in the decision support system to translate that into irrigation recommendations. They partnered with Valley, and they're allowing us to test that product at our field site. The field site is in East Central Nebraska. Part of our interest was testing this technology in a subhumid climate and some of the specific challenges to that. So for the sensors that we're using, an IRT infrared thermometer is one of our primary sensors. We have these mounted both on stationary posts in the field. That's sort of like our ground truth. We've done a lot of that in science. We're confident in that data, but also mounting them on the pivot lateral. That's the part that we're really interested in. By the way, the pivot already is a platform moving around the field. So the idea is to take advantage of that as a robot, as it were, to collect data to inform our agricultural management. We also use the thermal camera on an unmanned aircraft to be able to compare the data. Next slide. So we're also interested in multispectral data, and that gives us vegetation indices like the NDVI that help us track the crop growth of the different crop stages. For us, we're interested in that because we relate it directly to water use. So we mounted these reflectance sensors again on the center pivot lateral itself. Wanted to see how that works and how the data compared to other sources of data. We also had a sensor on our unmanned aircraft system, so we compare that. And for these vegetation indices, we also took advantage of satellite imagery. One of the exciting things in crop management the last few years is the increasing amount of satellite imagery that has become available. We're using Planet Labs imagery in particular, and that is a daily product that gives us 3-meter resolution. Okay, so in our project, so we've just finished 2 seasons of data collection. The larger scope is to implement our irrigation scheduling and decision support system and evaluate its effectiveness. But our first step was to take a look at data quality and its usefulness. So we started with the vegetation indices. You can see here the smooth lines are from the satellite data. We had both rain-fed and irrigated treatments. And by the way, you can see the difference later in the season as that rain-fed got drier, significant difference in the vegetation index. But also we captured that with our sensors on the center pivot lateral. So those are the dots, and they also picked up in the difference between and irrigated. On the soybean, we also did a lot of unmanned aircraft flights there. And so the X's and the plus signs indicate those. This is a nice confirmation. So we've got data from 3 different platforms: satellite, center pivot, and unmanned aircraft, and they're all telling us the same story about the crop development. So if you've been involved with work in canopy sensing, like this, you might know that the vegetation index is a little bit easier to get a measurement that we're confident in, but the thermal signal is the one that's a lot harder. It's a lot harder to get a number that you're really confident in with the canopy temperature. And so we did comparisons again from the stationary versus ones mounted on the center pivot, and then also from the unmanned aircraft. What I'm showing up here is this is data from the sensors mounted on the center pivot. We had 4 different treatments. Earlier I mentioned irrigation, but we had 3 different irrigation treatments. One was full irrigation, one was over irrigation, and one was deficit irrigation. And so if we look at those 3 treatments, if we could go to the next slide, please.
Yep. Oh, sorry.
Yeah, that's all right. So we go forward.
Sorry.
Yeah, that's it. Perfect.
Sorry.
Oh. So back one. So here, if you look at our different treatments, this is our canopy temperature, more specifically crop water stress index, CWSI. But the rain-fed has the highest temperatures. We would expect that on a rain-fed plot that's under stress. Deficit irrigation has some higher temperature. And the coolest one is the one that was over-irrigated, that has the most water in the system to remain cool. This is for a series of 4 days after a rainfall event. Now, the really exciting part here is that we were able to pick up a stress signal, even though it didn't have a large impact on yield. Rain-fed, of course, impacted yield. Deficit, some impact. We were able to pick up this stress signal. And that's one of these challenges of using canopy temperature in a subhumid climate, is to measure that stress signal before we actually have yield loss. Okay, next slide. Okay, so I'll wrap up here. Again, I really want to thank the people who have supported us, also many staff and students who have helped in various ways, a lot of team effort. But we're excited about these thermal indices and sensors on the pivot lateral, again, to track that crop stress and move towards automating the irrigation system. Thank you.
Thanks, Derek.
This is Tim. I have one quick question. Can the host hear me okay?
Mm-hmm.
Okay, yeah. Yeah, so you started out and you mentioned about let's say the rate of uptake of automation, et cetera, that you're seeing. How do you think this work, and then you mentioned toward the end, the relevance to that, how do you think this work will or could lead to more adoption of technologies and resulting increased efficiencies in irrigation?
Yeah, that's a great question. So from my view, which is kind of a broad high level view, I look forward to industry comments later in the panel, but I think barriers to adoption include partly the time commitment to really do a good job with irrigation scheduling with the tools that we previously had available. Now we have a lot of new tools, and so one of the barriers is uncertainty associated with those tools. So, producers have access to all sorts of data products. Can we be confident in those data products? Are they really helpful for making these decisions? So with this line of research, the idea is if we can improve the product, especially the decision support system, and increase confidence in using this system, then that would foster the adoption process.
Okay. Thank you, Derek. It's a very important component of the work that you're doing, and look forward to the industry folks following up with that later in the session. Let's go to our next presenter. That's Dr. Jay Ham. soil moisture sensors for irrigation management. Jay, please take it away.
Okay, well, thanks, Tim. And Derek did a great introduction to my topic because it's all about using sensors to improve our irrigation management. And I think we all realize that, you need to measure probably the parameter that you're trying to manage. And the whole point of irrigation is controlling moisture in the root zone. So I think we all agree, hey, soil moisture measurements could really be useful for irrigation management. But like Derek said, there's really low adoption rates of soil moisture when you look in both landscape irrigation and in ag. Next slide, please. So I just picked out a couple of articles from Irrigation Today. There was a new one by Salih Tagbagian, and great article talking about, there's a lot of opportunity to start using soil moisture in our irrigation management, but there's a lot of still very poor adoption. For example, several different surveys show that that's on the order of 10% of all irrigators use some sort of irrigation soil sensor. But, I think really actually when you go out and if you looked at it in terms of the number of acres that are, you did it on an area basis, I think it's really teeny. I think it's like, more like 1%, right? So we still have very few acres where people are using soil moisture sensors. And we'll talk a little bit about why that's the case. Also, Derek's presentation really dovetails this article that I wrote in 2019 called Irrigation 4.0. I think Derek is really right. The automation of the irrigation process is just so prime right now for development because of not only the sensors and improved irrigation systems like the one Derek mentioned from Valley, but also, the developments in data science, AI, machine learning, things like that. So I think, if we were imagining this session 50 years from now, right, there'd be all kinds of AI, machine learning type thing discussion and about that stuff. So that's coming, and we're kind of the group that's dipping our toes in this new technology. Next slide, please. So why don't people adopt soil moisture sensors? If we really need to measure it, why don't they use it, right? So some of the issues. One's poor integration with the control systems and decision support, right? They have the gadget in the field, it's delivering data, but people are not, it doesn't help them actually make that decision or trigger the irrigation system, right? There's a lot of field logistics and connectivity problems, right? People don't like putting stuff in their field, right, that they have to plow around or cultivate around. There's also connectivity issues, right? Like, can I get wireless connectivity with my cellular, Wi-Fi, LoRa? There's just an economics, like return on investment sometimes, right? Do we really get, if we invest a bunch in soil moisture sensors, does it really pay off? Does it really increase yield? It's funny, we work a lot in landscape irrigation, and a lot of time people will invest in a lot of soil moisture sensing, and their water bill goes up, right? So they don't like that, right? You get a few neighbors talking about that. Well, pretty soon nobody wants to put in soil moisture sensors, right? And then there's also these sampling and calibration issues, right? If you show up at a farm and start talking about this, the first question is, well, how many of these things do I need? Where do I put them? How do I calibrate them? So just like Derek said, there's a lot of time and effort involved the way it's currently being used. And we need to think about that as an industry and as researchers. What do we need to do to change that? Next slide, please. I think, the other cool thing to remember is we've already got a lot of great soil moisture sensors, right, that are commercially available. And I'm just barely scraping the top of the iceberg here. There's a lot of them, but, I kind of divide them up into three parts. We have our research type sensors that we're all used to using. We have some really good landscape sensors, as well as lots of new ones that are available for ag. So, we already have a lot of sensors made by really good companies with really smart people. But again, why don't we see more adoption? And is there something else that we need to look at? Like, are there gaps when we go out and talk to producers or urban irrigation managers, what do they really need? Next slide, please. So from the work that we've done, and we do a lot of what we call customer discovery interviews, is, to me, I think there's a couple of areas where we as a group can make contributions. One is really basic research on completely new approaches to soil moisture, right? Like completely different, something new, not capacitance-based sensors, not TDR, not some of the other methods that are very common, but new things. And we'll talk about that here in a minute. And the other is really low cost, open source technology that can be used by small stakeholder farmers around the world, right? When we look at surveys, you know, still what, 80% of the world's food is produced by small stakeholder farmers, right? And so they need technology too, and it needs to be really low cost and very useful. So I think those are the two areas where we can really make an impact. Let's see, next slide, please. Yeah. So one of the areas in this sort of cutting edge technology is wireless underground networks. And there's been a lot of research in this area, but it's really growing. This is putting radio transceivers under the ground, right? Maybe even below the plow layer, where you're collecting sensor data on soil moisture status, maybe salinity, temperature as well. And that network establishes itself and then is eventually transmitted above ground into the cloud, where it can be used in control systems, you know, kind of like Derek's system that he was talking about. It's a challenge, as you might guess, sending radio signals underground. Soil moisture, water is a good barrier to a radio signal. And so, but I think it's a really exciting area to watch. And it's an area where we're working some at Colorado State and getting some support from the IIC to look at some of these things. Next slide, please. So one of the places that we're working is this idea of just putting a low-cost, small radio transceiver in the soil. And we put multiples of these in the area where we want to sense soil moisture. And these little tubes, they're about 1 inch in diameter and 4 inches long. They don't have anything in them really except a battery and a radio transceiver, usually a LoRa transceiver. So there's no sensor actually. There's no electrodes on the side of this tube. There's no capacitance sensor. There's no TDR. Basically, we just set up a little radio network in the soil. And as you might suspect, as soil moisture increases, it degrades the wireless network, right? The signal strength among nodes decreases. When we send packets of information between the two nodes over wireless, that degrades. The time required for the radio wave to actually travel from one point to the other increases as soil moisture increases. And of course, the opposite happens when it dries. It's kind of like, you know, the number of bars on your Wi-Fi signal or your number of bars on your cellular signal when you're out driving around, right? And we can correlate the performance of the network with soil moisture. So it gives you this really, you know, we're kind of using network performance characteristics as a way to measure soil moisture. And we've only been working in landscape with this so far, but we're really interested in trying it in ag as well. Next slide, please. So on the other end of the spectrum, we're doing a lot of work with, you know, small stakeholder operations, including gardeners. We've seen in Colorado this massive increase in the interest in gardening and urban food production, especially in response to COVID. So we're developing really low cost open source sensors that people can use, put in their gardens or in kind of peri-urban ag situations and collect data and give them kind of a nice way to.
Sorry, I'm not sure.
That's all right. No worries. I'll just keep going here. So, you know, I think that's a really important thing is you got all these small stakeholder farmers around the world, and they all need a way to also measure soil moisture. And we're talking about sensors now that cost, let me see, I thought I might have one here handy. Sensors that cost, you know, maybe $2 for us to make, right? That low. So when you start making soil sensors that cost $2, right, and you have all kinds of opportunities. Thanks, Susie. Next slide, please. So these are some of the ones. We make all kinds of them. Gardeners are kind of particular about sensors that they want. So we make some that cost, that measures moisture at 2 depths and measure temperature. And like I say, all of these have a bill of materials. I think the ones I'm showing here, it's $1.60 in parts, right? So when you, like I said, when you start making sensors this low in cost, they're very useful. And we integrate that with Wi-Fi and can have a system that can measure maybe 5 or 6 soil moisture points in your garden, connect it to Wi-Fi, connect it to your phone and all that, for the whole thing costing like $25, right? So this is something that people are really interested in, and it's been really fun testing these with gardeners, and it's been really fascinating to learn what kind of mistakes they make and what they can learn from using these soil sensors. Next slide, please. So the other area where we do a lot of work, of course, and you can see up here in this slide, we do a lot of work in turf grass and landscape. This is work supported by the Irrigation Innovation Consortium. And like I said, when you can make sensors for just a few dollars, we make hundreds of them, right? So this addresses sort of the issue of, I need a lot of sensors and I need to spread them out across the landscape to deal with spatial variation. And I need a really low cost way to connect them to the cloud, right? So we develop a lot of this technology ourselves, gateways that allow us to connect all these different kind of sensors up to the cloud and to decision-making tools, and generate different kind of dashboards and things like that that you see down here that people can use. And we've done a lot of nice work with the golf industry. That's a great place to test technology because you've got such a great user base and highly trained professionals. So really nice place to do this kind of testing. Next slide, please. This is our, on the right is a picture of our wireless gateway system. One really great thing about this is that it can connect with cellular, LoRa, or Wi-Fi. And you see these little connectors along the side. You can actually connect almost any sensor you can imagine to that, and it will automatically determine what kind of sensor it is, will automatically adjust and send the data to the cloud for display and notifications. So it's kind of getting back to this automation that Derek's talking about. The user can hook up soil sensors, IRTs, weather sensors, and just scan the QR code, and they automatically get a dashboard that'll show them the data. And we bury a lot of this below ground, so there's nothing above the surface. You can see on the left here, picture from one of my students, Ian Axlin. He puts everything in these little valve boxes below the surface, and we've used these in a lot of places in urban systems. People are driving golf carts and such over the top of them. No one knows they're there, right? And they can run for over a year on just a small set of batteries. So keeping that kind of invisibility across the landscape is kind of important in the urban landscape scenario. Next slide, please. So, our systems, even though they're using low-cost sensors, they generate sort of the typical soil moisture data that we're used to seeing, where we can see the fraction of field capacity and see the dry downs and set thresholds where we want to trigger a notification, or in some cases automatically irrigate the plants. Just kind of demonstrating that you can generate this kind of data with low-cost sensors and start using that. We've also done a lot of work on automatic calibration of these sensors, right? Using machine learning algorithms. So once someone installs it, they don't have to really calibrate it for their soil type. It will, after usually 2 or 3 dry downs, it'll start honing in on what the field capacity is and what the threshold for triggering is. Next slide, please. So just to wrap things up, we've got some our newest iterations of our low-cost soil sensor. We're excited about. We have different versions, but they operate at 75 megahertz, so they're fairly insensitive to salts. They do use the capacitance soil dielectric permittivity strategy, have really nice output, They're waterproof, weatherproof, easy to make, and less than $5 in parts. And we've recently added salinity detection to these as well. So our plan is to make all of this open source. That is, we'll post all of this technology on the internet and allow people to copy it, duplicate it, make it, and hopefully improve it. So create, sort of a community of users around starting to move soil moisture sensors into more adoptability for irrigation management. And I'll stop there.
Jay, that was very, very interesting. I've got about 25 questions for you, but I'm going to have to postpone some of those, and I'm sure they'll be coming out in some of the dialogue. Especially interested in the scaling and market side of some of these technologies that you're developing there under your research grants. Let's move to the next speaker. That is Inge Bisconer with Surf and Earth Enterprises. She's going to talk about insights on irrigation industry needs. I'll go straight away to Inge, please.
Thank you, Tim. It's a pleasure to be here and speak in this esteemed session. I have learned a lot already from the previous speakers, and I look forward to the rest of the session. My presentation today is on some of the insights on the irrigation industry needs that we have been informed upon by a project that I've had the pleasure of working on this summer with IIC staff. It's a survey on industry needs. So on the next slide, I'd like to preface my remarks with a few slides, basically, stating what our current state of irrigation technology is in the United States. When we think of where we are and where we're going, well, where we are right now in terms of how we irrigate in the United States is a mixed bag still. As you can see on this graph, we have steadily been marching forward with drip irrigation adoption in the United States since the 1970s, when the USDA started its farm and ranch irrigation survey. So that's what this graph is. We can see that gravity irrigation in yellow has slowly declined, and that pivot irrigation, sprinkler irrigation, rapidly increased during the 80s and 90s and even into the 20s here, as you can see. So out of a total of about 57 million acres in the United States, about over half of it has been converted to sprinkler irrigation, and a little less than 10% overall in the United States has been converted to drip, and still about a third of it is in gravity irrigation. When we speak of what are we doing to move towards more efficient water use and energy use, often that coincides with the discussion of, are we adopting more water efficient technology? So as you can see, we are, but there's still a ways to go. And on the next slide, I'd like to highlight California, which has a little bit of a different story in that go back a slide, please.
Oh, sorry.
Went one too far. Okay, thank you. So in California, we have just under 9 million irrigated acres out of the country's 58 million. And we can see that drip irrigation, drip micro has been, more rapidly adopted in the state than in the rest of the country. In fact, about 60% of the country's drip irrigated acres are in California, and that's largely due to the crop mix, the higher value crops that can afford the adoption of drip irrigation. But you'll also see that we still in California have nearly 4 million acres of gravity irrigated farms. So we have a lot of opportunity for improvement, both in the country and even in the state's highest drip irrigated region in California. So next slide, please. So on this slide, I would just like to highlight that, adopting more efficient irrigation technology does not necessarily automatically mean that we're irrigating more efficiently. This is a study that was done by UC Davis a number of years ago, and it was an analysis of mobile laboratory irrigation system evaluation data. that we have done here in the state, and this was for 458 farms. And we see here that only 20% of the mobile lab DEU data, the distribution uniformity data that they derived from a test, is what I would call good, in the 85 to 95 percentile range. 30%, a third of them were in the 75 to 85%, and over half were less than 75. So there's a number of reasons for this, but I think you can kind of sum it up that a lot of these systems, even though they may have been great when they were purchased, either they have been misinstalled, mismanaged, something is going wrong here, and they're not operating very uniformly. So there's opportunity for improvement even where we've already adopted new technology. And so next slide, please. And we often, in my career in industry, it's always been, well, we just need to do more training and we need to provide more professional services, either classroom or field. But I think we're seeing that, this interface between the grower and all these other entities that have an interest in irrigating more efficiently, there's lots of room for improvement. So fast forward to the next slide, and the exciting project that I've had the pleasure of working on this summer is the IIC's Irrigation Industry Survey and Needs Assessment. And this is a project that seeks to find out what do we need to be doing differently to do a better job of being more efficient irrigators and energy consumers in both agriculture and landscape. My slides previously focused on agriculture, but the topic does include landscape, of course. So the following few slides will describe this project and kind of give a summary of it. And basically, well, I'm sorry, Amber, if we can go backwards one, not quite yet. So the survey that we developed had 20 questions. And it went to over 15,000 individuals, thanks to the IA's generous allowance of us to use their membership mailing lists. And also the IIC staff and myself provided a number of names for this database. But, we asked where people were working and how important water and energy footprint knowledge was to them, and what were your tech-related challenges, and hey, do you conduct research or partner with others? And if you do, with whom? And then most importantly, number 5 listed here is what sort of knowledge do we need to gain in order to do a better job? What research areas are needed? And we talked about material science, energy and hydraulic science, agronomic and irrigation related, on and on and on. Number of topics here, and then open-ended questions at the end. So that was the official survey. And next slide, please. And as you can see, out of 10,000 that were sent out, or 15,000 that were sent out, we got 414 responses, which doesn't sound like a lot, but in the survey world, that's an okay response. And most of them were from the landscape sector, but a good number from the ag sector. And many of us work in both ag and landscape as well. Then we also, zeroed in on who were these folks, and whether they were industry folks, consultants, on-farm practitioners like farmers and, university personnel, and government and utilities, landscape contractors, and educators. So next slide will show. This is an example of the results being crunched into very nice bar charts on the left, courtesy of Amy Kremen, and a histogram view on the right, courtesy of AJ Brown at IIC staff. They did a great job of converting this data into something that you can visually start to get a handle on, other than numbers. And this is an example of one question's results. How important are the following irrigation technology related challenges to your work? And you can see on the left one, dark green and light green means that they were very important or moderately important. Incorrect use was a huge issue of what the challenges are. And lack of awareness and affordability. There were some regulation and liability concerns, but does not address end user needs. data and output are not actionable, so forth and so on. And on the histogram view on the right, we see the same data delineated by the role, whether, who said that? Was it the consultants? Was it the educators? Was it the government folk? Was it the industry folk that said that lack of awareness, for instance, was the major challenge for them? So we are now in the process of crunching that data and generating a report. Next slide, please. That will help inform us of how to go forward using that data. So the second half of this project has been to conduct video conference interviews, Zoom interviews with industry stakeholders. And actually 3 of those are on the panel today, I believe, people who we interviewed. These interviews were 15 to 60 minutes long. People were very generous with their time. And we did complete 20 of these interviews and asked the following 6 questions. Do you think it's important to know the water and energy footprint of ag or landscapes? Why or why not? And what sort of irrigation technology related challenges do you or your customers face? And what kind of research do you think is needed to improve irrigation and energy efficiency? And do you partner with others, and could you envision being a partner with IIC? So these were highly informative, really rich in content interviews that we captured with notes, and it's all available in a gigantic Excel spreadsheet for later perusal by anybody who wishes to look at it. So that in partnership with the survey data is helping inform us of how to move forward. So next slide, please. So as I said, we're in the process of creating this report and drawing conclusions from both the survey charts and the interview content. And I just might add that you can get data from a survey, but you don't get the rich content that you get from talking to human beings like we did with the interviews. This paragraph that was written was in green. That was from the interviews. That the need for water and energy benchmarking data was voiced repeatedly as a necessity to currently go forward and inform us on regulation, conservation, carbon market, and sustainability efforts. We need to meet customer demand, and customer demand is hampered by wariness of regulation. So those sorts of nuances come out with interviews that you don't see in survey data. Next slide, please. So there were a ton of different themes. I know that we're behind schedule, so I'm just going to let these stand on their own. And folks, there will be a great report out soon that you can refer to and help inform your activities, whether you're in industry or education or otherwise. But basically water and energy footprint that loomed large, very large. People knew that was important, and we need to deal with that and get more information on that. And then the lack of user friendliness of the technology. And the previous 2 speakers spoke to that as well. We've got to do a better job either automating it or doing a better job of getting it in the hands of people who can use it. So next slide, you can see there are couple pages here of all the survey result major trends, and go forward another slide. And another major theme was that there are many important areas of collaboration, and that we would, the IIC has a real opportunity to partner with others and solve some of these problems. Okay, next slide. And we'll go to the next slide. And then, one final thought is, as we talk about climate smart ag, you can push the button for the first image. Water efficient, water use efficiency is often just a tiny little component of the whole CSA scheme. And in the next graphic, I'd like to propose that, for irrigated agriculture, water use efficiency should be front and center. I mean, leading agronomists agree that, 70–80% of the field calls they make for, plant health, it's got to do with water, not bugs or fertility or any of the other issues. So water use efficiency should loom larger in our discussion of climate smart ag, in my opinion. Alrighty, I know that we're running late, so I'm going to wrap up and leave it to Tim to move us forward to Amy, and I look forward to her presentation.
Yeah, thank you, Inge. Those points you make there, there's a lot to talk about there. And I just, as you said, there is a report that will be coming out very soon. We'll be having a webinar. We're going to have lots of other activities where we are able to have the opportunity, let's say, to get into some more of these details. So we'll make that known to everyone on this call. And we'll also have a chance to talk about it here later in this session. So with that, let's move straight to Amy Kremen. Amy's the project manager for the IIC, and she's going to talk about next steps. Please, Amy.
Hi there, everyone. Thanks to Water for Food for hosting this session, and to all of our esteemed colleagues who are with us today. We're so appreciative to have you with us. If you could advance the slide, Susie, please. So I get the advantage of being sweep, which means that our previous speakers have already, Derek and Jay and Inge, have done a great job of teeing up a lot of the themes that I'm going to build on during this talk, including, in moving through providing a quick spotlight on some other IAC projects that haven't been featured. And then we'll use that to segue to sort of ideas of what comes next. Next slide, please. Oh, wait, actually, before you do that, I just wanted to just go back just a sec. Just on the left there, wanted to mention that if any of you are interested, please visit our website. That image on the left is a report that goes into some detail of the 30 or so projects. As Tim mentioned before, we've had many projects that we have helped support over the years that the IAC has been active, and there's a really beautiful summary that our communications specialist, Susie Hutton, has put together that is available right from our homepage. And you can follow us there and also on all your regular social media. Okay, thanks, Susie. So as you've heard already today from the suite of discussions, so far the IIC has been looking at supporting many different ways. There are so many spaces and places to advance effective water and energy use for irrigation. And so we've covered, all kinds of things today. All the bullets you see have been mentioned already. There is an emphasis to that last bullet at the end. None of this happens without that peer-to-peer exchange and people actually getting help with troubleshooting, and that's a key component. The human interaction and learning and knowledge, and combining intuition, the hands and the hands and the mind. So there's the intellectual science part and the science-based stuff with also what the mind knows about what works in a particular space and place. And so figuring out ways to combine all of this stuff that humans can do, what we think, what we perceive, is just at that stage that Jay mentioned. We're ushering in all kinds of new ways of doing things and merging that with what we know on the ground. Next slide, please. And so, many of these projects, obviously, as you've noticed, they're all about harnessing the power of data. And there's so many ways the IIC has been working on supporting different projects. So whether it's combining, models and machine learning with online tools, as we've already heard today, or combining multiple things in integrated fashion to advance and support irrigation decisions. There's also sort of these higher level things that end up happening where you can see how within a regulated landscape like water is, that you can find out whether both local and state and federal policies are actually working to help us achieve water sustainability goals or not, and how to inform how those might need to change. The end goal, of course, of all of this is to sustain resilient and productive landscapes. And irrigation is only becoming more important in that space, as Derek alluded to in his talk at the start, that as we have climate change pressures and also pressures with water quality and quantity declines, mitigating risk and sustaining production and irrigation only becomes more important in those contexts. Next slide, please. So on that note, I'll just run us through a couple of different very high level overviews of some other projects that we have that are currently active. This one is from our partner, Dr. Dilruba Yasmin at Fresno. She is currently working on a project that takes public data sets, publicly available data sets of many different kinds. And she's figuring out how to interrelate those data sets and create, actionable data sets and other products that would correspond to 18 California counties that are involved in all manner of orchard production. this is based on work that was done about a decade ago, where they interviewed a bunch of growers and about in situ soil moisture sensors, and they found out a lot about people's hesitance and willingness and about to use different kinds of in situ technologies. And so they wanted to follow this up and sort of find out about using remotely sensed technologies, what people were willing to use and what not, what is working, what isn't. And they can use this database now also. They're going to combine that with a survey, and they can actually see, because of water stress over these 3-year periods of times, which fields may not be using any precision irrigation technologies at all. And this will allow them to actually target and find ways to develop programming to engage those growers in knowing what's available now and what the potential benefits and ROI might be of integrating those technologies. Next slide, please. So in another remote sensing project that involves our partners in Colorado, Nebraska, California, and Texas, we had different kinds of testing of microsatellite and different drone flights to figure out how you could use that to trigger irrigation decisions, how to understand how to use all these different kinds of images to really know when to dial in water use. In this particular case, the outcome is that those drones, in many cases, the data is time-consuming to download, to process, to make actionable. In some ways, the microsatellites right now have a more a product that's available for use daily. Derek alluded to this in his talk. And the project, in the end, identified additional research gaps that are super important about how to use the technologies as good as they are and as useful as they are and easily used as they are, and combining them with more ET-based algorithms to understand how well they're performing. And it also highlights this need that once we test out all these things, just creating easy front-facing dashboards that integrate all the information from the remote sensing, the ground in situ data, from soil moisture sensors and ag weather stations, putting this all together. People don't necessarily need to know what's under the hood, but all this testing is finding out that you can do this and you can do it with accuracy. So if we can make it simpler, that should help with some adoption. Next slide, please. So this is a lot of text on this slide, and I apologize for that. This is a very exciting project that is all about figuring out if you can use electrical consumptive water use to estimate electrical use data to estimate consumptive water use data. This is a project that is now in its 2nd year, and what they're doing is this is part of a regulatory. There's a regulatory context associated with the Twin Plat NRD in Nebraska. The Natural Resource District there is looking to encourage its growers in its area to be more aware of their water use in real time, and they want to be able to maintain and respect state regulations regarding water use district-wide. And so they're they've got this wonderful interactive dashboard where growers themselves can see their actual consumptive water use in real time. And it's all based on, it's basically near real time. Every 15 minutes as their electrical system gives data, this is converted with an algorithm to produce an estimate of consumptive water use. And what's nice, what the IIC research is doing is helping to fine tune that so that they know, when an end gun is on and off, does the algorithm perform correctly? What happens when you have changes in the aquifer from which the water is being pumped? How does the algorithm perform then? So the preliminary results of this work are extremely promising, and one of the most exciting things is that with electrical data available in many places, that this kind of approach to helping growers and districts understand consumptive water use in real time is highly scalable. Next slide, please. So then turning to some other topics, looking at the intersection of water and energy, I'm going to talk about 2 projects really quickly. This is an exciting one, again at Fresno, with nitricity. So they've come up with a way to develop, to basically capture nitric acid as an output from solar production and turn that into a product that can go through a fertigation line. And the IIC funding was used to do a test plot of commercial tomatoes. Next slide, please. So here you have this, here you have the system, and as we know, input costs are super high, nitrogen among them. Finding ways to actually scale different kinds of income generation on the landscape. So solar with agricultural production, is an interesting idea for, ROI and whole system economics. And so, as you can see, what they've been able to test now is that the system is on track to produce 200 pounds of N in the course of a year. They have discovered that, the pulses of nitrogen that they can put through the system allow them to actually produce a great crop of tomatoes. The regular, smaller fertigation may end up actually produce the same results in terms of quality and yield, and using less nitrogen overall. So they're moving from test fields towards commercial scale now with that project, which is pretty exciting. Next slide, please. And we've got additional projects involving solar panels now, looking at different heights and different kinds of uses around them. And I'm not going to spend a lot of time, but this topic is called agrivoltaic. So as we look at different ways to stack things on the landscape, it's interesting to see how, partial shade provided by solar panels can actually be a benefit for irrigation. So we're looking at that space as well. Next slide, please. And so you can see on this slide, results just from this season, there's some water benefits, and you've got that partial shade. You can actually grow production crops that may end up needing less water. And this is particularly in places like Colorado or Arizona where we're doing this research. This could be a huge benefit. Next slide, please. We don't have time to talk about this, but as you know, we're looking for places and spaces where we can improve decisions, use more water more effectively, and just find all the places and spaces where water could be used more effectively. And so even on golf fairways, where typically you have sort of a blanket application, there's ways to move towards a precision approach. Next slide, please. And so where does that take us? Can you move to the next slide, please? Thanks. Great. So as I mentioned before, we're looking always at the market context. And, as I mentioned before, irrigation is getting more important. And in some of the ways, the change that's needed is being driven by shareholders and big companies because they're worried about the interruptions to supply chain as water quantity and quality decline. And also we've got this regulatory context, which is growing. All these things are drivers where people are looking to see how water is being managed for long-term, vital landscapes. And so IIC works in this space to bridge between different groups, and we're looking to expand how that happens. So including the manufacturers and connecting that to all the different irrigation reliant groups. And we need to situate how we do our research within this context of, what is happening with the supply chain, what is happening with the regulations, and to move forward. Next slide, please. And there's of course very important constraints. The irrigation industry and even universities and others, we're siloed, we're competitive. So we're trying to find these gaps where we can add value to the industry in the near term and the long term. And doing this in a way that provides it's engaging sort of instead of a market-driven theory of change, we're sort of moving towards more of a social systems-oriented theory of change. So understanding how stuff gets out and gets innovated, how innovations get out and used in the landscape. And that has to, it's kind of inclusive of all the social factors, the economic factors, the landscape factors, policy, and education that can go along with helping everybody sort of know what the potential possibilities are in this space and why it might benefit them. Next slide. I think we've said all these things, so I think I could just wrap it up right there. Thank you very much.
Thank you, Amy. It was very, very stimulating. The whole series of presentations is very well orchestrated and actually integrated in a way. But I would like to just turn right away and start go to our panelists. For me, I wanted to start with a perspective from Weston as a starter, Weston Carey, being a farmer, being a teacher of precision agriculture on the ground at a technical college in Nebraska, having a background in consulting. I think his background, maybe for me anyway, would be a really good leadoff hit here to get our panelists going on our responses to or just our questions and ideas and just a riff, if you will, off of what we've heard today. Weston, would you say some things? Take over. Give us some ideas.
Absolutely. Can everybody hear me okay? First of all, thank you thank you guys as a team for inviting me to be a part of things. Amy was kind of my connection to you guys as a group, and I have a lot of energy on this subject. I was born in Colorado in Weld County. I'm a country kid, and I spent my first 40 years in Colorado, spent a stint at Colorado State University, and started some precision agriculture curriculum in my time there after spending 20 to 25 years in the engineering industry there. And my experiences in Colorado led to kind of what we're doing now out here in Kansas. We're in Goodland. Northwest Kansas Technical College is a vocational college that became accredited 15 years ago, and they've been there for 56 years. And it was a choice that I made now 7 years ago to come out and teach something I believed is very much the next way forward in not only irrigation technology, but in how we're going to work with better soil health, better food health. We're talking about natural resources, and as we move farther into 21st century, and that's this workforce scalability. I come out of industry. I've heard great presentations today of the technology out there, and our land grant institutions have done a phenomenal job about giving us data, what works, what doesn't work. I think the conundrum is it comes down to, do we have a workforce in the rural places, the small places, the places that don't have as great of, I'm not going to say they don't have a quality of life, but it's a different quality of life than maybe a lot of us academics, traditional academics, are used to surrounding ourselves by. When you're living out in a very arid place, 3 and 4 hours away from any metropolitan area, what's your motivation and what's your education and what's your ability to support these technologies? We have a lot of the same technologies on our farm over the last 7 years, our technology farm, right down to putting just about every type of soil moisture sensor into the soil, working with various forms of NDVI and remotely sensed data. And we have about 70 different partners across the industry, some in water, some in not, giving us equipment, asking us to do research. Although we're not here to do research, we're here to turn things over to two specific demographics. And that is, our young people have to go back to their small towns and become the people that support this technology for the next 10, 20, 30, 40 years in their hometowns. So we have great companies like Netafim, and we work with Ribulus products on our farm, and Valley and Lindsay and Ranke, systems that are all out there, and they're all doing very innovative things. The challenge becomes, who is going to work for these companies and the dealerships and the distributorships all across the footprint when we're representing not only hundreds of millions of gallons of water, but even more than that. We're surrounded out here, guys. Water is such a serious scenario that 3 years ago, we went into a limited enhanced management area. We're in a Lima constraint right now where we need to grow our corn and our wheat and our barley and our irrigated stuff off of less than 15 inches of water. So we're at a point now in a political climate where young people are, and not just young people, our producers also are now constrained with either A, hitting the bottom of their wells because they chose not to in previous generations, or B, there is now regulations on how much water we can pump, and that is one form of forcing adoption. The problem is it's also created a pandemic in the fact that we have producers in our area that routinely call me and some of our other faculty going, I need a guy, I need a gal, I need somebody, who do I lean on to put this equipment in? And we're finding that the companies that literally have the technology and the solutions don't have the people. So it does come down to education, but it comes down to something different than undergrad and grad level education. It comes down to boots on the ground, go out and get dirty, almost like a philanthropy or a missionary, for lack of better terms, mindset to actually go out and say, I'm going to spend my time putting this equipment in, servicing this equipment in the middle of the hot summer and in the middle of the mud, in the middle of the insects. You have to keep all those bigger picture things we all talk about in place with 18, 19, 20-year-old young, either producers going back to their farm or even a smaller subset of our group they're going out to industry, and they feel overwhelmed with the political and climate culture, and they feel overwhelmed with their lack of support in their small towns. And so there's a challenge. If we were to talk to any of our partners as research people, if you said, well, how are your dealerships doing? The technology's there. How are your dealerships and your distributorships doing with getting that technology adopted in front of day-to-day producers and having support personnel that are going to make this scalable? So I know that was a mouthful. You guys see why I teach, and I'm passionate about this, but it's the scalability of these solutions that I think it's the reason I worked in Colorado, guys. I worked in Boulder County for 8 years. And this kind of hit me in about 2012. And I want to make this comment. Boulder County was in the middle of really pushing a 0E kind of a footprint at the time. And a lot of our lead certified engineers that were working on various projects, and there were a lot of government rebate programs to put in, different kinds of plumbing programs and zero scape irrigation. And it was going across, like you said, municipalities, golf courses, and of course, suburban living. And they reported the information between saving 400 to 600 million gallons of water that for the first year they initiated the project. And everybody felt pretty good until you compare that math back to just center pivot irrigation alone, which is prominent out here and in eastern Colorado and in Nebraska and down in Oklahoma as well. That only represents 20 to 25 center pivot wells. So yeah, we have so many people who are aware of the water problem that are working on things in suburban areas by masses. And I'm not going to say they're not making it. We are not making an impact, because I've lived that way before. It was one of my reasons to go, I'm going to pick up and I'm going to go. And I'm going to go someplace where the problem is a huge magnitude. And I want to try to do something about it. Is because we can have so many people who are concerned and have the head and heart to do it. We have the technology out there to do it, but where it's really critical, where the gallons are being pumped, we're not getting the message. I'm convinced, my personal opinion, we're not getting the message out far enough, fast enough to the producers. We're not getting the equipment into the producers' hands, even with cost share programs and NRCS and EQIP and all these other things that are out there. The adoption rate is not keeping up with the depletion rate. And the workforce is also not keeping up with what we're going to need to actually accomplish if we're going to make a dent in this. So I didn't mean, you asked me to start this off.
No, listen, that is a great kickoff you got for us there. Your perspective, as I introduced you from the ground, if you will, is extremely valuable, and it's just a great setting for us to all be grounded in what you see on the ground and what you see is important. I'm gonna use that to segue over to maybe John Farner, who's has a lot of ground experience as well, but he's also working around the globe now. And so I think his perspective, segueing from yours, will be very interesting. John, you want to chime in here, and I'm curious what you have to say about this whole series of topics here.
Thanks, Tim. First of all, I appreciate you all convening everyone here today. I think it is a very useful and valuable discussion talking about the real world implications and opportunities that result from research that is a result of partnerships between government, university, and industry. So I think that's also very important. Also, know we're running short on time, and my good friend and colleague Jake LaRue is up next with a question. So I want to make sure that we provide ample time for him to give his perspective as too, given his experience working on the pivot side. But what I'll say is that, and I think Weston talked about this very nicely, is that we need to find a way to translate all of this research into real world application for farmers, making a difference to improve their productivity, their yield, along with their environmental sustainability. I'm the chief sustainability officer for Netafim, And one of the things that I like to talk about are the three pillars of sustainability, and that's economics, social, and environmental. So farmers are going to make decisions based on what's best for their business. I forgot who mentioned smallholder farmers. If it's Daryl or one of the presentations talked about smallholder farmers. And globally, the majority of farming that is done globally is done through smallholder farmers. So all this great research and technology development that we're doing at Netafim or Valley or our competitors are doing across the board, we need to find a way to provide these smallholder farmers the opportunity to use that technology. And so I know Netafim is a partnership with Bayer globally, where we are pulling the smallholder farmers together to share resources and provide some management opportunities for them. But these are the kind of things that we need to do. We need to think about to make sure that not only the larger farms are implementing these, but smallholder farms as well. And I'll wrap up my comments kind of reacting to some of the things that Weston talked about as well. A lot of the times we're seeing change occur too late, specifically in the United States. Weston, you talked about some of the challenges that you have growing corn and other crops given a small amount of water. And we need to make sure that before farmers are in a situation like folks are in Kansas or North Texas, or even what we're seeing in California now, that change is happening earlier, that we're becoming more sustainable in our practices, going towards a climate smart agriculture philosophy, right, Inge? To use your term you brought up in your presentation, that these changes need to occur a lot quicker, so we're not in the scenario we're in right now that we're seeing throughout the United States. So with that said, I appreciate the work that the consortium is doing. I appreciate the partnership that you guys have with industry, along with university and government, because I think this is where a lot of these adoption opportunities are going to exist.
Thank you, John. Very, very relevant comments and a very relevant perspective. We'd like to ask Jake LaRue another very relevant perspective. Jake, would you add some comments to from your view?
Well, I'll certainly try, and I'd also like to say the same as others have said. Thank you for the opportunity to participate in this. And I guess a drum that I've been beating recently with a number of different growers that I work with and dealerships that I help out periodically is the idea of setting goals. We've really seen some potential to, we talk about irrigation efficiency and application efficiency, all these wonderful things. But at the same time, from a sustainability standpoint, can it get us there? And do I really need to be shooting for 300 bushel corn, given the inputs it would take, even if they were available? Is it efficient? Or can I make a good living at 200 or 180 or whatever the number is? And I've been trying to help promote that concept more, and also the whole variable rate irrigation, which I don't believe has been mentioned much today. Yes, you can spend a lot of money and get some very advanced systems, but at the same time, with the control panels available from all the manufacturers, speed control can help move you a long ways forward. So that would just briefly be some of my thoughts and comments. And also, it is so critical, good research work that's done different places, that we get it down to the farm level. And I know Weston has mentioned that, and John, it's all important. We got to figure out how to get it to the growers, because I talked to some growers and they look at me like, what are you talking about? I never heard that before, which I don't believe, but for some reason it didn't soak into them. So with that, I'll turn it back to Tim to figure out where we're going.
Right. Thank you, Jake. These are very interesting topics. As I say, there's lots and lots to talk about here. I thought I'd just circle back and ask a few specific questions. Go back up to the top. Jay, you mentioned early on that, about the adoption rate and using soil moisture sensors. And just very, very briefly, I mean, I guess the first question is, why should anybody use a soil moisture sensor anyway? What's the point? And then you talked about the barriers, but how do you get through the barriers? To make that a useful technology that really does result in either improved productivity or savings of water, or both. How do you see that?
Yeah, thanks, Tim. I think, the key thing, when you think about our irrigation scheduling strategies that we use now, right, of the few producers that still use them, right, it's still a small amount. It's a water balance strategy, right, where people are using estimates of evapotranspiration and doing a quick water balance. I grew up in Southwest Kansas, still remember my dad, he turned on K-State radio at noon every day, right? Pulled out a piece of paper and they reported ET, and he scratched that down, right? And he did a little water balance calculation, right? And that was it, right? And we're kind of still doing that, right? And in many ways, now we're using a lot more technology, but the trouble with all the water balance strategies is that there's no feedback on actual moisture in the root zone. So the water balance models get off, and you can have some significant errors. So I think the great thing that soil moisture sensors do for you is they give you that direct measurement in the root zone. They give a way to automatically trigger an irrigation or automatically stop an irrigation, right? And so it really dovetails back to some of Derek's work on automating the irrigation process. I think that's sort of the way to the future. That takes a lot of the pressure off the producer and lets them sort of manage the technology without having to get into the weeds on how it actually works.
I have to mention, I saw about 15 years ago, the first time I ever saw anything like this was a digital high resolution board outside of water district office that was kind of flashing like the old time and temperature flashes that we used to have on the banks, in the small towns. A lot of them still do. But this thing was flashing the temperature, the time, and the evapotranspiration. And the first time I ever saw that was out in way out in a rural area of Morocco. And they were growing, very intensive, high value crops. And this was kind of sensitization technique to get farmers aware. And then, of course, our project was trying to, improve efficiencies in water management. It did a great job at, introducing the concepts. So I think that, taking that all the way to, as you say, automating, the irrigation technologies and techniques. I'd like to hear what Derek has to say about Jay's comment there about going to automation and what you see as, the factors, and what do you see as the future there? And how do you think your thermal sensors also can be effective there in the real time on the ground?
Yeah, that's excellent question. So obviously Jay and I think a lot of like. I've really enjoyed his presentation and had a lot of great insights. I think automation is probably one of the big puzzle pieces going forward. I think these thermal sensors can play an important part of that. Obviously, soil water sensors are really valuable as well. One of the things I've thought through is we have these different sources of sensors and data, soil water sensors, thermal sensors, and lots of other things. And they each have some uncertainty. If we could pull them together to a final recommendation that has less uncertainty because we're combining those data sources, that would be really slick. And that really gets us to that machine learning that Jay was talking about. And that the machine learning part's outside of my wheelhouse, but I think as we go forward, that will have a growing importance in giving us recommendations that growers are confident in and that work consistently.
Mm-hmm. Yeah, good. And yeah, sorry, I heard
I want
something.
to echo exactly what Derek said there. I think it is the closer we can get pivot irrigation scaled out in a way that our HVAC units work in our house with a sensor, and you just set the parameters and it runs itself. We all just go about our lives and come home and it runs itself. Or like our cars are running so many simultaneous sensors and redundant systems. The sooner we can get there and make it price effective, I think we're going to have a solution.
John, how do you see this, John Farner, playing out in globally? I mean, we're all mostly focused here on the Western US. What's your perspective on this, John?
I think a lot of, first, thanks for the question. I think a lot of the regulations we're seeing globally are a bit more advanced than what we see in the United States. A bit more prescriptive, especially in Europe with the Green Deal that has been passed. I mean, they're regulating from the drip perspective. They're regulating even the components of materials we use in our manufacturing processes, let alone to how it's used on farm. So I think that what we're seeing globally, it really depends on the market. Where Europe, of course, very big market, we're seeing significant regulations with how water specifically used, how chemicals, nitrogen fertilizers, pesticides are applied to enhance water quality. So we're seeing it a bit more advanced in that area, but then other areas, it's still the Wild West, so to speak, Tim, where it's highly unregulated and we're not seeing water managed that well whatsoever. So it's really a mix of what we're seeing globally in terms of water use opportunities, and specifically relating to what we call the smart controllers, digital farming and opportunities that they bring to the table in farming.
Is there a correlation between regulation and availability, or or is that sort of random?
Wow. Well, there's correlation and causation, right? So my expertise on regulation is in the United States, Tim, and I'm now beginning to look at this globally as well. It's what we're seeing in India, European Union, other nations within Asia and other parts of the Pacific. I think regulation is very reactionary, Tim. Very rarely is regulation done to stop something from happening. It has already happened. So we need to regulate it from continuing to get worse. We're seeing that in all parts of our daily lives, let alone agriculture and how agriculture policy is developed. So I'll take, for instance, irrigation. We would love to see some drought mitigation technology such as irrigation, efficient irrigation, brought to the Corn Belt of the United States, highly rain-fed agriculture states, Iowa, Illinois, Missouri, but their opportunities to invest in that are very low right now. There's not many cost share opportunities because they haven't irrigated in the past. So next time a drought hits, you have a lot of disaster assistance happen. So regulation it helps, but it doesn't drive change with ample time to really make a significant impact in order to stop environmental impacts from happening. So I don't know if that answered your question or not, Tim, but that's what we're seeing quite a bit throughout the United States.
It certainly points to the complexity of all these topics and how much interrelation everything we have, all the way from government regulation internationally to on the ground, what's happening. Yeah. Okay, so we're at time, y'all. This is how it goes when you have such a great panel with so many interesting topics. I just want to thank everyone for your time here. This is a fabulous collection of expertise, and thank Water for Food for putting this on, for Christopher Neal coming on there and his team. It's been an excellent opportunity for us to get out in front of you all and your stakeholders. So we just want to say thank you. Any closing remarks from you, Christopher, or anyone else from Doherty?
Thank you, Tim, and your colleagues at Colorado State for organizing this session. It was very informative, and thank you for all the speakers and panelists. I think it was a great session. Thanks again for all your work.
Thank you all. Very, very interesting. We have this recorded, so we're going to mine this. We've got a lot of good comments and information here. And once again, just thanks to everyone.